Welcome to day 7 of the SAT course. Today we're going to go over ratios and proportions. And for ratios and proportions, some of this might be review for you. Typically, we learn about a lot of ratios problems in middle school, but we're going to go over some common solution strategies for ratios word problems. So a ratio is usually comparing two different values, but sometimes we're going to see ratios that have more than two values. So we'll be comparing, let's say, maybe three items of one kind. We're also going to look at how to write a ratio as a proportion. So a ratio can be expressed in many different ways. It can be expressed as a fraction. It can be expressed with a colon, or it can be expressed just with words. And I think the easiest way to write a ratio is as a fraction. Let's look at a word problem example here. So when we have ratios in word problems, the order of the ratio matters. That is very important. And I think this is a great example of looking at the order and making sure that the order that we're writing these ratios in is correct. So here it says Jamal can eat 20 jelly beans, and in that same time, Smith can eat 16 jelly beans. The ratio of the number of jelly beans Smith can eat to the number of jelly beans Jamal can eat in that same time, we can write as a fraction. Now, the order matters. So it says Smith to Jamal. So even though Jamal's is first in the word problem here and Smith's is second, when we're comparing the ratio with Smith and Jamal, it says Smith to Jamal. So we have to write this in the other order. So it's going to be 16 to 20 or 16 over 20. And this reduces to 4 over 5. So we can write this as a fraction 4 over 5, or with a colon 4 to 5, or with words 4 to 5. And these all mean the same thing. Let's look at another example. Here it gives us the total. So it says the Lewis siblings consist of 15 children. If 6 of them are boys, what is the ratio of girls to boys in the Lewis siblings? So for this ratio, we're given that there are 6 boys and a total of 15 children. So if we just use these numbers, we could say there are the ratio of boys to total is equal to 6 to 15. But we don't want that ratio. We actually want the ratio, of girls to boys. And so for girls to boys, we don't know how many girls there are, but we can easily figure that out. So we have the total is 15, and there's 16 boys. So 15 minus 6, that's going to be 9 girls. So there's 9 girls, and the boys, there's 6 of them. And we can reduce this fraction. We can always reduce fractions, and the ratio is going to be the same amount. So we can divide that by 3 over 3, and we get 3 over 2, or 3 to 2. And now if we read this, it says 3 girls for every 2 boys. If this trend continued, let's say maybe it's the same trend with all family members, aunts, uncles, and cousins. Let's just say that we could grab a sample of people and say there are 3 girls to 2 boys, and then that we can use this number to determine how many girls or boys there are for much larger totals. And so that's what ratios are for. They are for using a small sample size and understanding what that ratio is, and then being able to make generalizations about larger populations. So there are 15 children, 6 of them are boys. and 9 of them are girls. We just subtract to get that 9, reduce the ratio. We get 3:2 for our ratio. We can also write the ratio 9:6 with a colon or 3:2 with a colon. Now, sometimes we have more than 3 variables. So in this situation, we cannot write it as a fraction. So this car dealership has 30 red cars, 45 blue cars, and 24 white cars. The ratio of red to blue to white is 30 to 45 to 24. So in this example, we can reduce this, but it's not really like we're reducing a fraction. You can think of it kind of as a fraction, where on a fraction, you would divide by the same number on both sides. But here you're dividing by the same number on all 3 sides, you can think of it as, or all 3 of the parts. So we're dividing by 3 on the 30, the 45, and the 24, and we get 10, 15, and 8. We can also express this like 10x, 15x, and 8x. That's just another way that you can write a ratio with variables if you need to. Here's another example with totals where we have to find the missing value, but we also need to write the ratio in terms of 3 variables. So here there are 30 animals at the pet store. 8 of them are dogs, 16 are cats. If the rest are birds, what is the ratio of dogs to birds to cats? So here we already know the dogs, the amount of dogs, and we know the amount of cats, but we're missing the amount of birds. We know the total is 30. So if we subtract 30 minus 8 minus 16, that's going to give us 6. So that means there are 6 birds left, and we can write this ratio just like that. And we can reduce this a little bit further. These are all even numbers, so we can divide by 2 on all 3 sides, and we get 4, 3, and 8. So the ratio of dogs to birds to cats is 4 to 3 to 8. You can write them with X's too if you need to. And that's just the solution there. A proportion is a fraction, is 2 fractions or ratios that are equal to each other. And you can set up proportions to figure out the missing values of a total. In this particular example, we're given the ratio of children to adults at a party is 2 to 3. So this is children to adults, and we can write this ratio as children to total, or we can write it as adults to total as well. So when we're comparing children to adults, this is called a part-to-part ratio. When we're comparing, so these are the 2 parts. If we add them together, we get the total. So 2 plus 3 is 5, and we get the total people. And this is called a part-to-whole ratio. And so is this one. This is also a part-to-whole ratio. So we can compare these values and write these ratios in 3 different ways: children to adults, children to total, and adults to total. Here's the next one. It says there are 33 students in Jeremy's math class. If the ratio of girls to boys is 4 to 7, how many students in the class are boys? So we're going to write our ratio of girls to boys. I like to write them like this, and then write 4 to 7 like that. Now, the thing that we're trying to find is we're trying to find the total boys. So what they've done here for this ratio of 4 to 7 is we've collected a small sample size from the class. So we collected a small amount of students from a class, and we found that in that small amount of students, there are 4 girls, 7 boys. Now we can generalize for the entire class to figure out how many boys that there are, if we know how many students there are altogether. And you can do this for much larger populations. That's one reason that we use ratios. So it's asking us how many students in the class are boys. Well, we know the total is 33. So I'm going to write a new ratio that's like boys to total. So boys to total, currently, we only know that there's 33 total. And we are trying to find how many boys there are. So I'm going to write B for boys. But we have to write another ratio that's in terms of boys to total. Right now we have girls to boys, but we can rewrite this in terms of a total ratio. And we can say that boys to total from that smaller ratio that we were given is 7 to 11. So we just add those together to get 11 for our total, 7 to 11. Now we can write this ratio over here, 7 to 11. Cross multiply, we get 11b equals 33 times 7. 11b equals 231. And divide by 11 on both sides. And that's going to give us b equals 21. So if there are 33 students in the class, 21 of them are going to be boys with this given ratio of 4 to 7. So when you're writing a proportion, you can always cross multiply if there's an equal sign. But also remember, when you're cross multiplying, you have to have the same units on the top and the bottom for both of these fractions. If you don't, you'll get the wrong answer. So for here, we put 7 boys for 11 total. If we put 4 to 7, that would be the wrong answer because that's not comparing the total anymore. That's just comparing girls and boys, not boys in total. So everything has to match when we're doing our units. All right, so some quick tips is be mindful of when you're given a part-to-part ratio or a part-to-whole ratio. Remember that the ratio can be written in 3 parts or even more sometimes. You can write it as just with numbers, or you can write it with variables of x afterward.